And yeah, welcome to Scaling Modern Software Development through Common Platforms. My name is Franz Schubert. I work for Giant Swarm. Giant Swarm runs and operates Kubernetes for customers and also the cloud native stack. I myself take care of customers, typically the larger customers like Telecom, Vodafone, and so on. And yeah, I've got Sebastian Zirch here with me, who adds the perspective of development to that area. So I'll just hand over to you, Sebastian, and yeah, would ask you to introduce yourself and then we can actually commence.
Great, yeah. Thanks for having me today here. So yeah, I guess I'm kind of the tech guy from both of us. So I have a strong background in software development, did a lot of Java and system integration projects for large customers. Yeah, before I moved into the cloud and Kubernetes space, that's where I now work as a consultant with viadee, and I'm also responsible for the competence center we have around cloud platforms and architectures at viadee. And yeah, we agreed to keep the advertisement part as short as possible, but I think it's kind of interesting to see why we're also doing this webinar here together, because viadee is a consulting company and we help our customers with everything around software development, and actually also really like to do the implementation work. So we're not that kind of company that, I don't know, stops at nice looking slides, but actually we really love to implement in code and yeah, to get the application set and running. So this is really where our DNA comes from. But the thing we don't like to do is operating clusters, operating infrastructure, and that's where we met with Giant Swarm and yeah, started a partnership this year. And you can also find more information about that on our blogs. So yeah, I think with that, we can go ahead and start. And what we have prepared today is, so we want to discuss a bit what are characteristics of modern software development and share our experiences, what we see in customer projects, and especially when they started with one project and then try to scale this to the second, third, fourth, or tens or hundreds of projects. And yeah, we'll then look at this, as Franz already said, from two perspectives. So from the developer perspective, what does a developer expect from a platform? And then on the other side, what does a platform team has of requirements to actually being able to operate this platform efficiently for everyone? And yeah, so let's start with why do we need modern software development at all? So this graphic shows the number of years until a product or technology reached the milestone of 15 million users. And for example, it took 62 years until 50 million people had a car or actually drove one, or 18 years until 50 million people were using an ATM to get some cash. And I mean, obviously, everything has become faster and faster. So for now, for example, Twitter, it took 2 years for them to have 15 million users. But yeah, I mean, Twitter was founded in 2006, I think. So already kind of an old company. So what do we see today with the really latest technologies and trends? Well, it took 19 days for Pokemon Go to reach 15 million users. And well, unfortunately, not only that, there were also a lot of car accidents and because of people running onto the street to catch some of these Pokemons. And this photo was taken in Düsseldorf, where they actually closed a lot of streets in the city center because it was simply too crowded. So developments today are pretty fast and disruptive. And another example here is the German fintech landscape. So if you're a banking company and yeah, still have like thousands of people writing, I don't know, COBOL code or good old Java 6 code and running your infrastructure manually. Yeah, I'm not sure if this picture would kind of scare me a little bit, because today you can build a software with a really small number of people who don't even own any infrastructure or hardware. So it might happen that other companies come into your market very easily, like N26, for example, did in Germany, and they created a mobile-only bank running in the cloud, totally focused on customer experience. What might even be worse, so maybe your biggest competitor is not even another bank, but it's Amazon. Or yeah, and you see Amazon as the biggest threat, like the ING, the CEO of the ING stated last year. The same threats are seen by other insurance companies. So why should you take care of modern software development? Well, because actually you need to if you want to cope with all these disruptive developments happening in the markets. And this is really about changing the way your culture works, changing how to write code, how to test it, how to deploy your applications, and even operate them in production. Because, if you don't do it, I guess someone else will come and do it for you, and that's definitely not a situation you want to be in. And from our experience, we see three kind of pillars to focus on. And the first one are really short release cycles. So it's super important to get customer feedback as fast as possible and being able to react to it and roll out new versions quickly. And to do that, you need to have independent teams. So you cannot have all your teams synchronized in your company because this basically slows down everything and simply not efficient. And therefore, in the end, you need a technology stack which is exactly designed for such use cases and makes a high degree of automation as easy as possible. And this basically is what cloud native is about. But still, there are different understandings about the notion of modern software development. On the one side, you have the customer demanding for new features being delivered as quickly as possible. And maybe you're also in a very competitive market that actually really forces you to react quickly. And then on the other side, there's a C-level who tries to remove any friction between teams and empower them to work efficiently. But in the end, if you bring it down, both the customers and the C-level wants developers that are able to think for themselves, to have end-to-end responsibility for their product and really work with a clear customer focus. And again, for the C-level, this means that they need to build an environment where developers get the necessary autonomy and freedom to do the right things. So that's also a lot about trust rather than a very tight steering of employees. And it really needs a culture to make this work. And I mean, obviously, this is also not for everyone. So you also need the right people that fit into such a setting. But today let's focus on the aspects here in the middle, and we will come back to them throughout the presentation. Basically again and again. So let's start a little bit with an architectural design pattern. So I guess all of you have heard about these microservices term and architecture design pattern. So the idea to organize services around business capabilities, having cross-functional teams being end-to-end responsible for their product, and acting independently from each other while still sticking to clearly defined APIs, because obviously all these services are needed to run your business for your customer. And I mean, as always, these design patterns, and also that's also true for microservices, they come with benefits and costs. So with microservices, you can, of course, have your teams or you can have your teams work independently at different speeds, and they can even deploy their microservices whenever they want. And you get these strong boundaries represented by the APIs, which are kind of enforced. And this is one of the downsides, because then you have a lot of remote communication going on between the services. And this adds a lot of complexity. So operational, but also topics like eventual consistency. If you have like a decentralized data management, then every microservice storing their own data. But I would argue, and that's also what we see in customer projects, with growing systems and growing organizations, the autonomy for teams becomes more and more important, and it outweighs kind of the costs of this increased complexity that comes with distributed systems. And this is true at least as long as you use a technology stack which is tailored towards those distributed systems and which takes care of the complexity originating from all these remote communications. So that's why it's so important to actually look at this cloud native stack. And just a little side note I want to add here. So microservices is not for everyone. So you need to do at least some homework before I would recommend you to start with microservices, because Yeah, the first thing is you really need to be able to spin up new infrastructure kind of within minutes rather than filling out Excel sheets and waiting for half a year until your hardware is delivered, for example. You need to have a lot of monitoring and tracing in place to be able to cope with errors you will definitely see in your distributed environment. And in the end, you need also a lot of automation because, well, with cutting your microservices smaller, you get a lot of them. So you have to deal with a huge amount of deployments. And you can only do this efficiently by using fully automated CI/CD pipelines. And these are things you should really take care of before you start your microservice journey, basically. So now, why do you need a platform for that? And what we see in customer projects is that usually the first projects, so the Lighthouse project, they start with using new technologies, making their first experiences. And this is absolutely great. And that's also what I would recommend to do. So not to plan too much upfront, but simply starting using the stuff instead. But with the third, fourth, fifth, 10th project, you might think about how to scale the stack efficiently. Because, I mean, obviously, not everyone can be an expert in everything. And it doesn't make sense if each developer has to deal with the full complexity of Kubernetes. So not every developer has to know how logs are ingested throughout the platform and are processed at a common logging solution, or how name resolution works in your networking layer. So that's why it makes super much sense to think about platforms and have a dedicated platform team dealing with all these cross-cutting concerns, and let the product teams focus on writing code that actually helps your customers, that helps your business, and ship those new features quickly. And now if you're talking about platforms, if you can get away with stitching together a couple of AWS services, that's totally fine. There's nothing wrong about it. But if you need a more flexible solution, Kubernetes might be your way to go. And please don't start building your own stack. So there's this nice tweet of Kelsey Hightower stating that Kubernetes is a platform for building platforms. And for doing so, you can then choose from hundreds of open source projects in the cloud native ecosystem. And this is what everyone else is using too. And this is also where all the community work happens. And this is super beneficial. So I would definitely argue for that approach in using and integrating all these open source projects. But in the end, when you think about a platform, you always have this trade-off between the flexibility you give to users, so your developers, and the degree of standardization on the other side to make the operations of such a platform efficient. And the sweet spot, I would say, it definitely depends on the people you have in your company. So you might have teams where it makes super much sense to give them full access to the Kubernetes API because they know exactly what they are doing and they fully, kind of leverage the potential. And on the other side, you might have teams that need kind of a higher level of abstraction because they simply want to get the application up and running and don't want to write hundreds of lines of YAML code to do this. So this really depends on, the people you have in your company, and you should really, look at the situation you have here. Now, having said that you need a platform, I would continue and argue you need a decentralized one. So with a single platform, with all the applications running on a big cluster, you need to update, and then you need to update your cluster from, let's say, V1 to V2. You need to synchronize all your teams again and plan a big release weekend. So then you get all the problems back you try to solve with your microservice architecture at the application layer, and you now have these problems back at the platform level. That's why I would argue you should give each team the capability to decide when to upgrade or update their cluster. So you should have each team running their own instance of a cluster, which is then, but each cluster can still be built on a standardized platform and serviced and supported by your platform team. Yeah, so this is really the idea of decentralization also at the platform level. And yeah, in addition to the aspect of decentralization, I would want to share with you the idea of thinking of a platform as a collection of APIs. So really programmable interfaces. So no paper-based contracts, but really APIs which you can use programmatically. Because, I mean, what is the idea of APIs? The idea is to hide implementation details. Yeah, so users don't need to only need to know how the logging format is supposed to look like. They don't need to know how the processing works under the hood. That's something the platform team can take care of. And these APIs also allow to use different technologies. So there's no need to stick every team to a specific logging library. Yeah, it's completely sufficient to simply state how this API, in this case, the logging format, looks like. And another aspect which is really important and maybe the most beneficial aspect of Kubernetes for many, many companies, it's not that much about scaling high peak loads. It's the most beneficial thing we see in projects is that it allows teams to interact in a self-service fashion. So they can simply provision infrastructure they need basically at their fingertips spontaneously at a specific point in time, and they don't need to order resources like half a year in advance. And if you do everything like that with APIs, you can even go ahead and test the provisioning of the infrastructure within your CI pipelines. This is also where your application becomes more and more integrated with your platform layer, because you can then leverage the potential the platform gives you, and you don't need to implement features like tracing or so at your application layer. So yeah, when you build a platform, think of providing APIs to your users with basically a lot of magic going on behind. And we will look at the details on the left in a second. But for now, again, just take away this idea of a platform as a collection of APIs. And yeah, the last perspective I want to add on this platform on this platform topic is the organizational perspective. So what we see working well is really have decentralized product teams working at different speed, independently from each other, and using the self-service infrastructure and provision what they need. And then have a centralized platform product team. So basically just another product team, but their product is the internal platform, which is then used by all the other teams. And yeah, and just to make sure that you're not confused. So having a central team taking care of the platform does not mean you have to run a single cluster. Yeah, so this platform team provides basically the blueprint or the scripts to spin up dedicated clusters with your standardized platform configuration for all the other teams. So yeah, having argued that you need a platform and how a platform should look like, we will now discuss it from these two perspectives. And from a developer perspective, I would basically expect the platform to take care of all the features on the right. So take care of runtime aspects like logging, tracing, monitoring, routing network requests. But actually there's much more. So you also need Git repositories. You need a possibility to build CI/CD pipelines. You may need a service registry to register all your microservices. And often it even helps to produce API documentations, yeah, in a standardized way and store them in a single place so that everyone has access to them. But besides these functional requirements, as a developer, I would also care about usability, about the trade-off between simplicity in the sense that I don't need to dive into all aspects of Kubernetes, but also the flexibility to let me choose the level of abstraction I want to have. So maybe I want to have this full access because I want to do, I don't know, the crazy stuff. Or maybe I just want to have access to Knative to deploy my microservice there and I don't want to care about the rest. And I mean, as a people, developers easily get bored when they have to do repetitive work over and over again. So as a developer, I want to be able to automate everything, also to ensure, consistent environments. So I want to have production exactly behaving like my Q&A in my dev environment, because this is the only way I can make sure that my application behaves the same way as well. And I also want to have full transparency. So being able to look into every component of the cluster of the platform, at least for debugging purposes, is also super important to understand what's going on and being able to trace down errors you might see during operations. And these debugging things are so much easier if the platform was built on open source components rather than a lot of do-it-yourself solutions where you cannot come back to a community or Google something, because it's only something you have inside your company. And another thing I want to add is because that's something we also see a lot in projects. People are asking for managed services. So if you're using one of the big cloud providers, say AWS, this is super easy. So if you need a database there, you just go to their managed database service and provision a database and you're fine. But if you are forced to operate on premise, well, you might think, as a platform team, you might think about providing managed services such as databases as part of your platform product, so that not each team has to deal with the complexity of running a database in containers on your platform. But when you do so, please make sure that everything is fully automated and people can provision new databases on their own in a self-service fashion via an API. So not by, again, calling you or filling out Excel sheets. Yeah. And what we also see in projects is what really helps is to provide blueprints and best practices for the standard tasks to make onboarding on a platform as smooth as possible. Now, some of the aspects we discussed so far might be already familiar with you, but I want to add another one, which is a bit more, kind of cutting edge and adds some more requirements to the to the platform's bucket list, basically. And we all know the idea of continuous integration. So where you test and build your code and then continuous delivery, where you actually ship your artifacts. And if you're using CI/CD and really taking it seriously, this is absolutely great because it means that a production deployment is nothing special anymore. So basically it's something that happens while you're having lunch or dinner. Now, the thing is that CI/CD allows you to fail fast, so you can ship your new increment to production with automated pipelines. But the thing is, when something goes wrong with your production deployment, you're basically on your own. So there's no tool support. So no one is reacting automatically. In best case, your monitoring triggers your pager, you leave lunch, and you get back to your desk and fix that. And this is where this term progress delivery comes into the picture. And the term was coined in a blog post I linked below, and I would definitely recommend to read this one. And the idea of progressive delivery is to roll out new features step by step. So you deploy to production, but then increase the traffic gradually. So first, for example, you give only your developers access, then some beta users, then a specific region, then you go into general availability, for example. And in case something goes wrong, so let's say you have an online shop and you change something in your basket microservices and in your basket microservice, and now the average size of your basket drops down to 0 after you rolled out this feature. And well, obviously, this is not something a business wants to see. And you can then define thresholds on those metrics and trigger rollbacks automatically, because you know something is not right with this deployment. But even if something like this happened, the good news is that it only affected the limited amount of users. For example, only your beta users, or in a lucky case, only your developers, only your internal staff. And this is because you roll out gradually and shift traffic gradually. And this way, you really get early feedback for new features in production. For example, you can also ask your beta users about their experience with a new feature. And you can only do this by bringing this to production because, well, your external users won't have access to your Q&A environment, for example. Now, the second idea of progress delivery is to do this promotion to the next stage in an automated fashion based on metrics. Yeah, so the idea is to see, okay, so for example, use these basket size, average basket size metric to decide if we are ready to go to the next stage. And another perspective on progress delivery is that you can make your release of a feature independent from the point in time where you deploy it to production. So when a new feature is enabled for a specific region, there might be, I don't know, marketing campaign as well. And so maybe the marketing team should actually push the red button and activate this feature toggle to make this feature available to a specific target group because they send out, for example, some mailing at the same point in time. So maybe the actual making the feature available should not be the same point in time where you deploy to production. Yeah, so that's where you can, for example, use feature flags to control this. Now, I think I already said most of the points here on the slide, but if you want to do progress delivery, it comes with 4 challenges. And these are basically things your platform needs to be capable of. And the first one is, well, obviously you need to be able to segment your users. Yeah, you need to decide whether a network request comes from your developer, from a beta user, or from a specific region. And based on that, you need to be able to route traffic to your older, to your new version. And then you need to be able to observe the actual state and health of your application. And not only from a technical perspective, like is CPU and RAM usage fine, but also from a business level. Yeah, be reminded in this basket size example. Yeah, and in the end, you use all this data to decide automatically whether you continue with your rollout or whether you roll back, and you do this automatically. Now, there's an interesting story about SpaceX. Maybe some of you followed the activities when they recently launched their Falcon 9 rockets to bring astronauts to the ISS and back safely to Earth. And there's a podcast, I think, below. Unfortunately, it's in German, so maybe if you understand German, it's interesting to listen to this episode, because they talked about why they reused the first stage, so those boosters, which then land vertically, as you see here in the picture. And the obvious reason is, well, it saves them a lot of money because this is the most expensive part of their rocket. But the second aspect is that components that are returned back to Earth can be inspected and improved. And this is something you cannot do if you leave the components in space or burn them while entering the atmosphere. So also for them, it's about iteratively becoming better and learn. And the second aspect they mentioned is observability. So when the components are then launched the next time, the particular areas where they change something are then monitored by GoPro cameras during flight. So every rocket, every SpaceX rocket has tens of GoPros in it, basically just collecting data during runtime, so during the operation, because then they use this data again to inspect and adapt. And this is something we should keep in mind as well when we write applications and operate our applications. So really provide endpoints for metrics that allow a high degree of observability. And I would even argue that the implementation of a new feature is only complete and done if it's observable by such an endpoint. And that's something really you should keep in mind when entering the microservice area. Now, there are different ways to do progress delivery, to do progressive delivery, but basically they all mean, as I said, that the platform needs to be capable of managing those scenarios. So, for example, you need the possibility to do these incremental traffic shifting from the old version to the new. So there's what is called canary releases. Or you can also do blue-green deployments where you basically have your two environments running side by side. One is live, the other one is standby, and then you switch. When you look at the area of front ends in UI, it's very common to use A/B testing. So roll out small UI changes and see, yeah, if the user experience becomes better or if the conversion rate increases with these changed UI. I don't know if the final shop button is red or blue, something like that is tested with A/B testing. And this idea to, as I said, let the marketing team push the button to activate a feature requires that you are able to have feature flags in your application, and then again route traffic, for example, based on how the feature flags and the user segmentation has decided on the target group. So yeah, that's again some points we need to add to the bucket list that a developer wants to see from a platform team. And yeah, with that bucket list, I guess I would like to hand over to Franz and discussing the other perspectives of the platform team operating all of our wishes we have as a developer.
Thank you very much, Sebastian, for giving us a perspective from a development team. As Sebastian said, and actually we've seen many of these demands from our customers also in terms of what the development teams want to do. I fully support the idea of having full flexibility. That's something that is actually a major blocker in many different platforms. Also, being able to go in and analyze and trace down to the root cause to quickly identify what is causing the issue and how to stop it from happening again. Yeah, I can fully see how you actually have made the same experiences as we have. So that's very nice to see. Yeah, so basically, as Sebastian said, I'll be covering the platform aspect, and I actually want to talk a little bit more about how platform teams operate and what the challenges are and how they come into place and so on and so forth. So let's start off with a very simple example of how typically larger organizations embark on a cloud native Kubernetes journey. And that's things that we have seen, in Vodafone and Telecom and in other places where you might have a team that decides to go fully cloud native, and they basically have then set up, let's say, an on-premise environment with Kubernetes. They have acquired a license for a fully fledged solution for that environment. They actually have built up their own team to manage that. They have got special requirements that are fully supported by that environment. And then suddenly, let's say that's team alpha, and then you've got team beta that basically has a project, and the project team and implementation team is developing this, but they basically outsource everything to that development team, also operations, and they expect them also to run Kubernetes for them. So that's basically where the service provider comes in and says, well, we'll just manage an EKS environment or whatever for the customer for that project. It's very limited, so it's easy to control. We don't have to go on the fully fledged version, which naturally is also a cost aspect. So yeah, then you actually have the second Kubernetes installation in your company, and then you've got the third one that basically says, yeah, we actually have we have very little knowledge, and we don't know how to start. We tried out EKS and it didn't work, and and then basically there was some configuration, and yeah, but we're not at the stage where we want to have a fully fledged version, and or we have certain requirements that are not covered or whatever. And then basically they start off, let's say, with a company that manages Kubernetes for them, and that actually works quite nicely. Then they actually get it works so nicely that the second team, like Team Delta started off, Team Gamma adds their needs to the platform, says, well, we actually want to use the same capabilities, so we'll add our applications onto your clusters. And then suddenly you realize that you need to do an upgrade, and then you need to coordinate, and suddenly you've got 3, 4, 5, 6 teams where you need to coordinate how to do these upgrades. And that actually is the moment where you actually basically decide to have a separate cluster where you might want to have certain requirements and so on and so forth implemented at a certain pace. and then you've got your third environment, you've got your fourth environment, and so on and so forth. So that's where actually that's a typical picture we see. So if that's something that's happening in your organization, don't be surprised. That's something that will typically happen. So when we actually then look at why that is a problem, we'll quickly come to two main points. One is naturally there's the inefficiency. So you actually have a team taking care of Kubernetes here, another one there, and a third one over there. So sharing the experience, the knowledge is something that that actually doesn't really happen or doesn't apply too much. If you actually find something's not going on, it has to be fixed in different environments. Security patches have to be deployed in different environments. You might have automation in place for your CI/CD pipeline as per Sebastian's requirement. Then that is actually optimized and built around the cloud native stack as you know it, and that's where basically that's where a lot of inefficiency comes from. And you also need to consider this. There's a cloud native space, lots of open source projects, lots of new projects being added on a yearly basis. I think the whole CNCF landscape, you can look up the interactive landscape. It's cluttered with projects that are coming up, and some are end of life, and then you need to evolve this, you need to advance it, and so on and so forth. So that's where another inefficiency comes from, and naturally then governance aspects. So you need to make sure that all the security is in place, the provisioning happens with the security in place, you've got access rights to the right people, management of these, and also running the upgrades as we just discussed. So there are many things that you actually do repetitively throughout the company that actually makes it obvious for you to kind of think about how to better structure your energies and focus them on a few or even a single platform. The other thing is that when you start off with your project, typically it takes time to establish it. So either install and get people trained, and then naturally also you do throughout the management of that environment, you actually will invest time, more and more time, and it eats into your budget. So that's where you typically suffer in terms of time to market. In the innovation cycles, they get longer because you're just distracted from the work. You also have aspects where your teams aren't cloud native ready yet. They actually need to learn the technology and they need to know how to apply it. There might be one team that actually is well supported by someone who actually is very well versed. Others that might just say, well, we know how to develop applications in microservice, but what technology and what do we need to consider? What takes pods down in terms of logging or other things that we actually see frequently. Also, misconfiguration is a typical source of pain in that environment. And the problem is, once you actually start investing time, it actually takes longer for you to deliver and to really reap the benefits of the cloud native environment. So one is really the overhead that you're producing. The other is it actually slows you down on your cloud native journey, which is something I most certainly started off with getting rid of by using cloud native in the first place. So having really more agility in that environment. So these are the typical areas that we see, and to address that, that's where platform teams typically come in. Either you already have that in your organization or you're establishing it, especially around Kubernetes and the related technologies. And they actually need to cover three main aspects. One, and typically it's actually reduced to technology only, though it's becoming often it's a technology decision, which is only like a third of the whole story, where you actually need to decide what technology do you want to build on, how do you want to typically you actually would use a managed Kubernetes environment, which managed means that it's they actually provide you with the upgrades, they've got the integration ready, and so on and so forth. So there are many aspects, but then it's either a basic setup that you need to extend, then there are changes, configurations that need to happen. So there are aspects that you need to take care of to really set up and customize to your project to make sure that it best supports the project that is at hand. The other aspect is that you need to run it then. So even if it's provided, like, upgrades are provided, you need to then do the upgrades. You need to make sure that you're aware of breaking changes, that you make configurations so you can direct and divert traffic. You need to set up CI/CD for further canary deployments and other things. So you actually basically make sure that everything works the way it should, and naturally you've got monitoring of the stack. You need to identify issues. Once you identify issues, you need to go and do root cause analysis and so on and so forth. So there's a whole lot of more that you need to do in terms of setting up the technology. And then and that's, I think, the most important aspect is the evolution of the platform. So in cloud native, it's a journey that never ends. So it continuously evolves. If you think installing Kubernetes is fine and you're done, that's the biggest misconception you can actually have. You need to think about evolving it and adding to the stack, thinking about how to best support the teams, how to do automation, as Sebastian mentioned, how to also evaluate new technologies. You've got end of life, so you need to think about new technologies. You notice that certain apps might not be as cloud native as your application is, so you need to replace them, let's say an API gateway or whatever, and then add more cloud native. So when you roll certain pods, they actually come up a lot faster than, there are customer examples where we actually had to wait for an hour for an application to start before we could roll the next pod. That's an environment that is not really cloud native, and that's what we're actually helping with a lot, making sure that you actually can embark on these opportunities. To get an idea of what a cloud native stack look like, because it's more than Kubernetes, we've got many people here that actually have heard about Kubernetes or cloud native, but basically need to get a basic understanding. It's Kubernetes is, and these are just the taglines that the CNCF uses to categorize different projects in the cloud native field. And Kubernetes is in the scheduling and orchestration field. Everything around it that you actually then see here, be it databases, application definition, image building, service mesh, and so on, is like basically around it, and you may need or may not need them, but the majority of aspects here you actually definitely need. And that actually is like, you need a storage, maybe permanent storage, you need a container runtime, you need a cloud native network so the pods can talk to each other, and so on and so forth. So these are all aspects that you need to kind of take care. So when you set up an environment, you actually need to make sure that these technologies are in place so you can operate on them. And you need to upgrade them, and you need to make sure that you can monitor them in case they fail. You need to configure them. You need to make sure that people have access rights to them, and so on and so forth. So that's a lot of things you need to take care of. And just to give you an idea of what an environment like that looks like, you actually might have, Quay for the registry. You might have Aqua for security, or a new vector. You have Vault for the keys that you actually want to store. Then you've got Calico for the communication between the different nodes. Then you have a OpenEBS for storage. Then you have Velero for backup, Kubernetes and etcd naturally to actually run the core DNS for discovery, DNS discovery, Nginx for ingress traffic coming in, and so on and so forth. And then naturally on top you've got the Docker for creating your containers, Flatcar for your operating system, Helm to install additional ads at the registry, Grafana for monitoring, Prometheus for tracking. So they're on logging. So they're and maybe the like Stack and Opsgenie for alerting. So there are many tools around it that you basically need to operate the cloud native stack, and that's something that has already been well defined. It's something that already has kind of been put together by vendors, in my area, in my perspective, it's actually nothing that actually really helps you make a differentiation, but it's a basic requirement. And if you basically want your platform team to take care of everything, that's what they actually need to have knowledge, experience, and time to deal with in terms of installing it instead of operating it and evolving it. And that actually makes it quite challenging. And hope you just get an idea of what that actually will look like. In terms of the activities you need to think about, that you conduct with all these different technologies, it has a lot to do with installing it, securing it, making sure that you've got robust access and pod security policies activated, that you actually manage, that you understand where the teams are, when they can upgrade, what challenges they are facing, how to solve it by applications, monitor them naturally. Then you actually might want to provide a certain SLA to the teams, and that's where you basically also need to make sure once you find an error somewhere, you can deploy it and fix it everywhere, and then you basically need to make sure that you run the upgrades regularly with the teams, either separately, as Sebastian supported, or you actually have certain teams together that are very, very similar in their requirements, and you can actually push upgrades regularly without even notifying, making sure that you basically are up to date all the time. If the cloud native applications are well enough, built well enough, then they can easily support that. Another aspect that we have seen, for example, with Adidas, is that they actually have, let's say you've got a certain environment that you actually have set up with the control plane and the different tenant clusters with the nodes, where you basically then have this environment, and managing that single environment is something that is maybe manageable, but then you have certain teams, and with the teams, you actually you have a web shop team, you have a logistics team, and so on and so forth. And they then, each of them might have a dev environment, a staging environment, a prod environment, and that then runs in different regions. And you quickly understand this is like something that is growing in terms of complexity. Managing single clusters is already fine. Managing 2, 3, you'll actually already feel a pain. If you actually go to 40, 50 clusters like we run for Adidas, that's where it actually really becomes painful if you don't have automation built around it. And either you actually get that automation from someone who already has built it, or you basically build it yourself, which naturally takes a lot of time and energy. And that's something you actually need to consider. In terms of the challenges that you typically see within teams, is that if you actually build up that functionality, the automation around it, and there are many, many more use cases that you actually can build where, or that I could share with you, where you need to build automation. It's something that the teams actually don't feel benefit from initially, because they run the cluster themselves. For them, running multi-cluster environment isn't a pain they feel yet. It might be later when they've got to several teams, and then suddenly need to manage the different clusters for the different teams. So this is a key challenge of platform teams, is they actually need a ramp-up time if they actually develop it themselves, instead of getting it out of the box. And that's something that actually is a key drawback for the development teams in terms of accepting a platform team as a help. The other aspect that you naturally have is that as a platform team, you actually don't own the projects that then deliver the new functionality. So that's where you can't force a product team that actually establishes a new product and develops a cloud native onto a certain platform. Typically, it's something that the platform teams try to offer it, but if it's consumed, they actually have no clue. And that actually makes it very difficult to budget them naturally, because they typically need to be cost neutral. And then also in terms of timeline, making sure that they can hit a certain timeline, but then identify that the development teams may need longer. So they actually have an infrastructure there running, and they need to update it and keep it running and whatever, is something that actually impacts the cost, and having nothing to really invest strongly because of a certain timeline and the business case behind that is actually quite challenging. And that's another big drawback we are seeing across the organization. I'm speeding up a bit to make sure we hit the 60-minute timeline. Unrealistic expectations is another thing. It's like, yes, a fully service actually would be wonderful. Do you need to have it from day one? Probably not. We actually have seen customers or companies start off on that journey thinking about self-service from the very start. We actually don't think it's something that needs to evolve over time. So it actually is a key challenge for the platform teams to manage all expectations and to get everything deployed and offered that the team demands. And that's something that is something. Typically, if you actually have single projects, that's a lot easier. If you've got across the organization many projects, then it actually becomes a pain, and that's where development teams or platform teams are not equipped to provide that as a value. And meeting the customer demands is also something they actually would like to do it. They implement functionality, but then sometimes you just need to say no. And having that experience on how to build a product is something that we actually have gone through for the last 6 years, because sometimes there are many ways of solving a problem, understanding what the real goal is and how to deliver it with the technology at hand or extending it intelligently so other teams can use it for different use cases requires a lot of knowledge and experience in cloud native application environments. And that's something that platform teams typically don't have. So basically, they're like the key challenge is really being able to deliver value, have the power to offer something that actually is used, making sure that customer demands are implemented, and also managing these customer expectations are aspects that actually need to be covered. But even if they actually offer everything, there's this IKEA effect. It's like, basically, if you actually have built something, you value it a lot more than if you actually haven't built it. There were research done by Harvard, by Yale, and Duke University found out that people actually who built something themselves, even if it's co-building, like with IKEA products, they value it 63% more than if they actually just acquired it as a full set. And that's something that actually makes it very difficult for platform teams to pull projects over. So when you start off and let the teams decide to build something themselves, don't expect it'll be easy to establish a platform team and really replace that in the environments. That's why we actually recommend think about your cloud native journey as a company. Think about how fast you want to get your teams on board and invest early, or get someone who actually can offer it on an on-demand basis based on the project size and so on and so forth, where you then basically can make sure that the project teams find it easy to get on board. What platform teams should be doing, very much of what Sebastian said, offering teams the value add that they actually are looking for, making sure that they actually have automation in place for canary deployments and so on and so forth, so evolving that constantly, making sure that security clearance and enforcement is there without having going through that cycle again, making sure that observability is there so the teams don't have to reinvent, that they are not different technologies for each and every cluster, simplified for the developers so they can actually move on very, very quickly and then actually think about evolving it. So I strongly believe this is something that you actually should be focusing on and not necessarily on the standard set like the technology and the 24 operations. That's why we basically offer that to customers and allow platform teams to really evolve and focus on where the value is for the development teams to bring them forward ahead. So in general, how do you start? Very simple. You actually get the platform teams and the development team together and discuss how actually what the project looks like, how to implement it, how to run with it. You actually need to make sure that the platform team understands how to deliver that efficiently, and at the same time, you actually need to make sure that the benefits that the development team realize to cloud native aren't consumed by an over the head of complexity within the teams. So you actually really have a win-win situation, and ideally you actually basically come to that DevOps cycle where you basically make sure that the different development teams can execute and benefit, and the company benefits from this agile development that Sebastian talked to at the very beginning. And if you actually are interested in talking more about it, Sebastian is here. I'm here opening questions. We actually help customers on a daily basis. viadee a lot in terms of how to set up development teams, how to make them cloud native, how to implement DevOps, how to evolve them. We actually talk a lot more about how to run the operation infrastructure and how to evolve the teams and the platform teams so they can both meet together and deliver the biggest value that you have seen. So with that, thank you very much for attending. I actually will open up for questions, and yeah, if you've got any questions, ask them here, send us emails later. Actually, I'm quite happy if you actually send them on to us, and we can get back to you. If you're interested in further webinars, we actually provide these on a regular basis. Make sure that we actually share our knowledge and our experience in the cloud native community. Very thankful for Sebastian to be here today, sharing his insight from a development perspective. And yeah, hope to see you again maybe on the 29th of September at the webinar in respect to security.